If our sun suddenly turned into a magnetar, we'd all be cooked, and pretty quickly. Magnetars pack about 1.5 times the mass of our sun into an incredibly small space. They're tiny and super dense remnants of ancient stars that have gone supernova, and they have an unimaginably powerful magnetic field. Yeah, this little star would kill everything on Earth, including you. In this video, we'll show you how life would change or end if we replaced our star with some of the most extreme objects in the universe. Some of these, surprisingly, could be better for us than the sun. But before we get into it, we want to hear what object you would want to replace the sun with. Why not tell us your pick in the comments below? Okay, now let's test them all out, starting with a red giant.
Oh my god! Oh dear! Are you filming? Yes, I'm filming!
The bad news is that the sun really will swell up into this kind of red and hot exploding star, and it would swallow Mercury, Venus, and even Earth. The good news is that it'll take 5 billion years to get there, give or take. You see, our sun is what scientists call a G-type yellow dwarf. It's a main sequence star. It runs on fusing hydrogen into helium, but its clock is ticking. The sun formed 4.6 billion years ago. A star like this only has a lifespan of 10 billion years. Only. And when it dies, it goes out with a boom. A red giant kind of boom. But we're not going to be around in 5 billion years to witness the death of the sun. So how about we speed things up and replace our star with the red giant now? Well, because that would mean instant death for you. Because as I mentioned earlier, this red giant would swallow Earth whole. You wouldn't even get a chance to enjoy the view. Immediately, Mercury, Venus, and Earth would be obliterated. And not because this red giant would be so scorching hot. No. The sun's surface burns at 5,772 Kelvin. That's about 5,500 degrees Celsius, or 10,000 degrees Fahrenheit. Red giants burn cooler, mostly because at this point in a star's life, it's burned up all of its hydrogen. This star's surface temperature would be around 3,000 Kelvin. That's just 2,700 Celsius or 4,900 Fahrenheit. But red giants got their name for a good reason. A giant reason, I should say. Yeah, this ball of helium would be 200 times larger than the sun. And it would be anywhere from 1,000 to 5,000 times more luminous. Even if you could look at it just for a second, you'd lose your eyesight. At first, everything would become very bright and orange. The sky would look like it's on fire. You'd be blasted by the most intense heat wave as temperatures on Earth rose by hundreds of degrees. Next, the oceans would boil and disappear. Within minutes, Earth itself would get dragged into the red giant's outer atmosphere. Our planet's crust would melt. All life would burn. The red giant would reach Earth's orbit, blind us, broil us, and then there would be no more Earth left. Gone. Even Mars would get a violent blast of heat. Its carbon dioxide ice caps and permafrost would vaporize instantly, creating a thin atmosphere of gas and steam. It sounds like great news for Mars, but it's not really. Strong solar winds and intense radiation from the expanding red giant would strip away that thin atmosphere in no time. The Martian surface would be hotter than the melting point of lead. All the sand and rock on its surface would melt into a glassy blob. For a short time, Mars would glow like a red-hot coal, but then it would just end up as a dead rock. Other planets further away would be affected too, because the red giant would gradually lose its mass. Its gravitational hold on Jupiter, Saturn, and the other surviving planets would weaken. Any planets that weren't burnt to a crisp would slowly drift away out into outer space. Okay, that was a pretty violent end for Earth. On a scale of how spectacularly we die, I'd rate it a 9 out of 10, taking a point away for not being able to enjoy the view, even briefly. Okay, next, let's go a little easier on Earth and replace the sun with a red dwarf star. Red dwarf stars aren't the same as red giants. These are the most common types of stars in the universe. Most of the exoplanets we find out there in space are orbiting this kind of star. Now, the sun will never become a red dwarf, not even in billions of years, but if it did, well, it wouldn't be so bad. First, it would become really small and dim. Red dwarfs are much cooler than our yellow dwarf sun. Their average surface temperature is about 3,300 Kelvin. That's 3,000 degrees Celsius, 5,500 degrees Fahrenheit. Replacing the sun with this kind of star would cause the skies on Earth to look dark and faintly colored. It'd be like a deep dusk or dawn, even at noon, with a small reddish-orange dot. It's so dim that you could look directly at the red dwarf for a brief moment without any eye damage. But because this new sun would be so dim, temperatures on Earth would start to drop by a lot. Within 1 week, the global surface temperature would fall below minus 18 degrees Celsius. That's 0 Fahrenheit. Within a year, Earth would be about minus 73 degrees Celsius, minus 100 Fahrenheit. The effect of this cooling would take time, but eventually, everything would freeze. The only place left that would still have liquid water would be deep under the oceans. At first, you'd see intense storms and heavy snowfalls, but eventually, the water cycle would stop. There'd be no rain, no snow, no wind, and there wouldn't be enough solar energy for plants to perform photosynthesis. Plants would be the first thing to die out, and soon after, the entire food chain would collapse. In this climate, only the hardiest microbes would have a chance. Some microorganisms deep in the Earth's crust or around hydrothermal vents in the ocean could survive indefinitely, but on the frozen surface, all forms of life would be wiped out. Over the years, the cold would become more intense, and even the near-surface bacteria would go dormant or die. Earth would become a sterile, ice-bound rock. Now, it wouldn't be all that bad because at least you wouldn't die instantly. You might have a chance to leave the planet and travel someplace more pleasant. That is, unless Earth itself took off out of its orbit. Here's the deal with red dwarfs. They're way less massive than the sun, so their gravitational pull in the solar system wouldn't be strong enough to keep all the planets in place. Earth might break off and become a rogue traveler in deep space, getting even colder, darker, and more inhospitable for life. And that would happen fast. Gravity travels at the speed of light, so Earth would start feeling the change as soon as 8 minutes after the sun turned into a red dwarf. Our planet wouldn't immediately shoot off into deep space. No, it would gradually begin drifting away, and then eventually we'd leave the solar system. But at least you'd still have a little time before your imminent death. So a red dwarf filling in for the sun, well, I give that a 4 out of 10. Okay, let's move on to something that's not very common in the universe. Turn our sun into a blue star. A blue star. Blue stars might look cold, but they actually run extremely hot. These O-type or B-type main sequence stars are the hottest and most massive stars in the universe. You don't see them very often. O-type blue stars make up only about 0.00003% of stars in our Milky Way galaxy. And our sun physically could never gain enough mass to become a blue star, but if it did, it would look interesting. Daytime on Earth would have an intense, almost stark blue-white glare. The sky would take on a deeper blue or even a violet tint. This blue star would be a lot brighter than the sun. Do not look at it with the naked eye. This bluish light would be overwhelming. Oh, and did I mention it would shower you in extreme levels of radiation? Yeah, Blue stars are monstrous. The blue supergiant star, Rigel, emits 60,000 times as much energy as our sun. And some blue stars out there, like Eta Carinae, put out 1 million times the energy of the sun. Even if our new blue sun were a less extreme blue star, Earth would suddenly be receiving hundreds to thousands of times more radiation. If you were exposed to this blue sun just for a few seconds, you'd get an instant sunburn from all the UV radiation. And just as quickly, the Earth's surface would start to heat up. Instead of a global average of 15 degrees Celsius, 60 Fahrenheit, you'd be dealing with temperatures of several hundreds to thousands of degrees. In a matter of days or weeks, Earth would heat up to the point where rocks and metals melt. The oceans would boil away and all life would incinerate. That would be the end of Earth. The good news is that if this blue star had the same mass as the sun, well, nothing else would change in the solar system. Would Mars become a little more habitable? No, but it would become less deadly than Earth for a short time. It would get warmer on the red planet, but the amount of radiation the blue star would bathe Mars in, well, let's just say we wouldn't want to be building habitats there. Blue star? I give it a 5 out of 10. Deadly, but not as dramatic as the red giant. You know, Chase has been dying to go to his star for his next mission, but we're not exactly sure where to send him. What star do you think we should send Chase to? Well, tell us in the comments below. Now, let's see if we can crank it up a notch and turn our sun into a neutron star. Neutron stars are epic. They're born out of a massive explosion called a supernova. It's one of the most violent and energetic events in the universe. The whole blast only lasts about 1 second, but in that second, a star releases 99% of its energy. This mega event can outshine the galaxy for weeks. Of course, there's no way you are surviving this kind of blast, and our sun is way too small to burst into a supernova anyway, so let's skip the initial blast and replace the sun with a neutron star in a more calm way, like this. Within 8 minutes of the last drop of sunlight, the sky would fade to black and stars would appear, even if it were daytime. You wouldn't see the moon or the planets because you can only see them by reflected sunlight. You wouldn't even see the neutron star in the sky. It would be practically invisible to your human eyes. From now on, it's forever night on Earth. And you probably know where this is going. Without sunlight, there'd be no photosynthesis, no plants, no life. Earth would gradually become a frozen rock. But it would be bathed in a different kind of solar energy. Neutron stars are unimaginably energetic, especially if they're pulsars. If this neutron star had a spinning core, that would make its magnetic field stronger. It would become a rotating, magnetized neutron star, or a pulsar. And now you'd be dealing with periodic blasts of intense, high-energy radiation. From Earth, these bursts would appear as an aurora-like glowing in the sky. With time, the effects of this radiation would become more intense and cause electronic disruptions, skin burns, and radiation sickness. Life on the surface would be wiped out from two sides, freezing from a lack of solar heating and being irradiated by the neutron star's high energy. Earth would freeze and fry at the same time. But once you zoom out a bit, things would be business as usual. The neutron star would have about the same mass as the sun, so it wouldn't disrupt the solar system's delicate orbital order. Neutron stars, way too radioactive. They sound epic. I wouldn't want to live close to one, so I'm gonna give it 7 out of 10 on the destruction scale. Okay, next up, let's replace the sun with a magnetar. Magnetars are extreme, maybe more extreme than neutron stars. Well, technically, magnetars are neutron stars, just with a little sprinkle of magnetism. And just like neutron stars, Magnetars are small, about 20 kilometers or 12 miles across, but their magnetic fields are trillions of times stronger than Earth's. Then here's a bummer. If you expect this kind of view, well, don't, because if the sun suddenly turned into a magnetar, you wouldn't see anything in the sky. That's because magnetars emit most of their energy in X-rays and gamma rays, not in any visible light you can see. Once again, just like with Jimmy Neutron Star, it would be all night and no moon. And here's another interesting thing about magnetars. These things are burning hot. I mean, all these stars are, but a magnetar's surface temperature is millions of degrees. But on Earth, you wouldn't get all that much heat from one. Again, they radiate their energy as X-rays and gamma rays, not as visible or infrared light that would warm Earth's surface. Plus, a magnetar's surface area is really tiny, so just like in the case of a neutron star, Earth would be blasted by deadly radiation, and it would freeze because of a lack of warming light. But unlike the neutron star, a magnetar would instantly fry our satellites and power grids. Its radiation is way deadlier, and it would also completely disrupt the Earth's magnetic field. A magnetar's intense magnetic field and gamma ray flares would violently compress the Earth's magnetosphere. And you want the Earth to have a stable magnetosphere because that's what holds the atmosphere in place and protects you and me from space radiation. Not only would Earth become technologically blind and deaf, it would also be showered in so much radiation you might turn into the Hulk. Yeah, brother. Ooh. No, not that one. The one who turns green. Yeah, well, that really only works in the Marvel universe. But hey, at least you'd get the view. There'd be incredible auroras in the sky. I was really looking forward to a magnetar. Epic! That's an 8 out of 10. Next up, the scariest and hungriest object in the universe. The black hole. Yeah, remember how I said that some of these extreme objects might be better for Earth than the Sun? Well, scratch that. Nothing is better than the Sun. And a black hole is definitely much worse. To be a little more gentle to our planet, well, let's say that this new black hole in the center of our solar system had the exact same mass as the Sun. Because a supermassive black hole, yeah, that one would just suck you in and not spit you out. But a nice sun-massed black hole wouldn't even disrupt the Earth's orbit. This epic view from Earth. Wait, that's not right. If our sun was turned into a black hole, you wouldn't see a fiery disk in the sky anymore. There'd just be, well, just nothing. That's because a black hole with the same mass as our sun would only be about 6 kilometers, 3.5 miles wide. Bummer, I know. But grab a telescope, you'll see that the space where the sun used to be isn't completely empty. You see, black holes bend light around them, and without the sun's blinding glare, you'd start noticing the stars in the background being smeared into arcs. This effect is called gravitational lensing, and it's really the only way you could see the black hole at all. If some distant star lined up just behind the black hole, you'd see something called an Einstein ring, a perfect circle of starlight wrapped around a pitch black shadow. But like I say, you'd need a telescope to see it. Now, as far as life on Earth goes, well, you and everyone around you would soon freeze to death. Maybe not immediately or overnight, because Earth would still have some internal heat. But after a few years, almost everything at or near the surface will be frozen solid. After millions of years, Earth's equilibrium temperature would get as cold as minus 240 degrees Celsius. That's around 35 Kelvin or minus 400 degrees Fahrenheit. And that's a complete freeze-over. Nothing would survive here. But on the bright side, at least you didn't get sucked into a black hole, so that's a 6 out of 10 for me. Black holes are dangerous and very strange. Even a nanosecond in one would stretch you out into a state of human spaghetti. Now, the closest one of these monstrosities is just 1,500 light years away, and I wouldn't recommend jumping into it. If you did, it'd be a cosmic nightmare. If you shrunk Earth to the size of this model, this is how large Jupiter would be in comparison. But to compare Jupiter to the Sun? Well, the Sun wouldn't even fit in the frame. You'd have to zoom way out. Yeah, if Earth was 12 centimeters, 4.7 inches in diameter, the Sun would tower at 13 meters, 43 feet. To Digipeter, holding his Earth model, the Sun would look like a school bus. And that's nothing compared to what you're about to see. Today, we're going bigger and badder to reveal the absolute largest objects we can find in the entire observable universe. And let me clarify something. We're talking physical size, not mass. We often talk about planets and stars as large and massive. Well, when I say large, I mean the diameter of an object, top to bottom. And when I say massive, I mean the mass, which is the amount of matter stuffed into an object. You can have an incredible mass, but be physically tiny, like a dense black hole or a neutron star. Those are not going to make it on our list, because today we're talking size, and things are going to get huge. In our own solar system, Jupiter is the largest planet we've got. Jupiter is so huge that you could fit 1,321 Earths inside of it. You could say that Jupiter plays an outsized role in our solar system. Huh? This gas giant may be the reason that a planet like Earth can sustain life at all. Yeah, because of its size and gravity, well, Jupiter deflects comets and asteroids so that they don't constantly slam into Earth, causing dinosaur-killing kind of events. Even more importantly, because of where Jupiter sits in the solar system, it helps the inner planets maintain nearly circular orbits. For Earth, a circular orbit means a stable climate over long periods of time. Thanks, Jupiter. Now, it may be the largest planet in our solar system, but it's nothing compared to the absolute largest planet scientists have ever found. Q Rox 42BB. About 470 light years from Earth, there's an absolute monster of a gas giant, Rox 42BB. If Earth was a ball 12 centimeters in diameter and Jupiter was 1.35 meters in diameter, Rox would be as wide as an elephant or a one-story house. And it's not just another exoplanet. Something isn't right about Rox 42BB. You see, gas giants are made of the same stuff as stars, helium and hydrogen. The only difference between them is how much mass they're packing. If a gas giant has 13 Jupiter masses, it starts having nuclear fusion inside and turns into a brown dwarf star. Now, Rox 42BB is a cosmic heavyweight, and it has a mass of 9 Jupiters. It's too light to be a star, but way too massive to have formed like a normal planet. Normal planets are built slowly, piece by piece, from the leftovers of a star's birth. But Rox 42BB might have skipped that step. Instead of growing from dust, it may have collapsed directly from a massive cloud of gas, just like a star does. But because it didn't have enough material to jumpstart nuclear fusion, it never ignited. That's what scientists call a sub-brown dwarf, a failed star trapped in the body of a planet. If you could drift through its thick, stormy atmosphere, you'd find that it still has a core that's glowing cherry red from the heat of its birth. Okay, if you're wondering why there aren't any supersized rocky planets on our list, well, that's because rocky worlds don't grow that big. The title for the largest rocky planet goes to TOI 849b. And if Earth was 12 centimeters tall, TOI 849b would only be about 40 centimeters in diameter. Yeah, rocky planets don't grow much larger than 4 times the diameter of Earth. But TOI 849b isn't just an oversized rock. It's a dead core of a gas giant that had all of its atmosphere stripped away. So yeah, when you look at largest planets, you gotta look at things like Rox 42b, a planet on the verge of being a star. And those are the next bigger, badder, brighter objects we're looking at. Stars. Stars are huge, and we have a pretty big one right here at home. The Sun is by far the largest object in our solar system, with a diameter of 1.4 million kilometers, 865,000 miles. It dwarfs both Rox 42b and Jupiter. In our size comparison simulation, where Jupiter is 1.35 meters in diameter, the Sun is 13 meters wide. Yeah, that's the kind of jump in size you get when you level up from planets to stars. The Sun is not just huge in size, it also accounts for 99.86% of all the mass in the solar system. That means all the planets, moons, asteroids, comets combined are just leftover crumbs, about 0.14% from back when the Sun was born. You're lucky that space is a vacuum and that sound can't travel through it, because if it did, the Sun would be deafening. Yeah, the Sun is so incredibly loud from its constant nuclear explosions that even from 150 million kilometers away, it would sound like a lawnmower vibrating at over 100 decibels right in your ears. On top of that, about 10 times a year, you'd be assaulted by the thunderclap of X-class coronal mass ejections, CMEs. These can release the energy of hundreds of nuclear explosions all at once. Now, our star is pretty special to us, but it's not the largest or most massive one out there. Neutron stars, white dwarfs, and magnetars pack a lot more mass, but they're all smaller in size than the Sun. Yeah, they crush all their mass down into a tiny space. And since we're talking about the size and not mass, those extremely massive space objects, they didn't make our list. And our Sun is a medium yellow dwarf. It's nothing compared to what we're going to find out there as we go deeper into the universe. Like this star, Sirius A, also called the Dog Star. You can see it in the night sky with your naked eye. Out of all the stars in our sky, Sirius A is the brightest. And not because it's the biggest, it's just very close. It's a mere 8.6 light years away, making it one of the 10 closest stars to Earth. But it is bigger than our Sun. It's about 1.7 times larger. In our comparison, Sirius A would be 22 meters in diameter. But compared to some of the largest stars, Sirius A is still just a small player. It's a bright, impressive neighbor for sure, but it's nothing compared to what happens when a star starts to reach the end of its life. Take Pollux, for example. It might be cooler than our Sun, but it's 9 times larger. Pollux is a red giant, a star that's begun to run out of fuel and is puffed up to a staggering 12 million kilometers in diameter. It's a bloated, glowing glimpse of the Sun's future. Yeah, this exact same thing will happen to our Sun in about 6 billion years. Scientists calculate that the red giant version of our Sun will definitely swallow Mercury and Venus, and possibly Earth as well. Okay, now, while Pollux is impressive, well, we're gonna go even bigger. This is Arcturus. It is a true giant, measuring 18 million kilometers in diameter. to put that in perspective, you could line up 25 of our suns across its middle and still have room to spare. Arcturus is 37 light years away. It's the fourth brightest star in our night sky, shining with the intensity of 113 suns. But Arcturus hides its true power. Because it's cooler than our star, most of its energy isn't light that you can see. It's heat. Yeah, this star pumps out 215 times more thermal energy than the sun, turning it into a cosmic furnace that would incinerate anything that gets too close. Arcturus is one of the oldest stars in our galactic neighborhood. Scientists think it might be a relic from a completely different galaxy that the Milky Way swallowed billions of years ago. It's an ancient extragalactic traveler passing through our corner of the universe. Still, as massive and mysterious as this giant is, it's about to look completely insignificant compared to what comes next. This is a literal supergiant, Betelgeuse. It's about 700 times bigger than our sun. If Earth was a globe 12 centimeters in diameter, this giant would be slightly taller than Mount Everest. It's so large that if you placed it at the center of our solar system, its surface would extend past the orbit of Mars and could even reach Jupiter. And now, Betelgeuse is ready to explode. Yeah, this giant is dying, burning through the very last of its fuel. In 2019, Betelgeuse mysteriously dimmed to 60% of its usual brightness. Scientists thought it might finally go supernova, but turns out it was an enormous surface mass ejection that coughed up a cloud of dust, temporarily blocking its light. Betelgeuse could collapse and explode into a supernova tomorrow, or it might hold on for another 100,000 years. In the grand billions of years timescale of the universe, that's less than a nanosecond. Today, we're bringing distant exoplanets closer to home. How much closer? Well, we're moving them right into our solar system. We'll start with TRAPPIST-1e. TRAPPIST-1e is a terrestrial planet, just a little smaller than Earth. Back in its star system, 41 light years away, this world orbits extremely close to its star. But it's okay because that star is tiny. Yeah, TRAPPIST-1, that's the star, is smaller, redder, and way colder than our sun. It's classified as an ultra-cool dwarf star. Nice. The distance between TRAPPIST-1e and its star is only about 3% the distance between Earth and the sun. And that's actually within the habitable zone of this tiny star, TRAPPIST-1. Now, when we were deciding where to move TRAPPIST-1e into our solar system, we thought placing it as close to the sun as possible would be a great move, but not at the same distance as it orbits its own star now, because at 0.03 astronomical units, our sun would crisp this world up like a piece of burnt toast. No, we're going to find a cozy spot for TRAPPIST-1e in the orbit of Mercury. The orbit of Mercury is about 0.4 astronomical units from the Sun. That means that TRAPPIST-1e would be orbiting the Sun 13 times further away than it orbited its own star back in its star system. But the Sun is bigger and hotter than TRAPPIST-1, so even in this faraway orbit, TRAPPIST-1e would be getting a lot more sunlight. The surface temperature on this alien planet would jump to extreme levels too, and this heat wouldn't take long to hit TRAPPIST-1e. No, this planet would become scorching in a matter of days. And within years, well, whatever water might be contained on this planet would boil away, so if we're thinking in terms of habitability, that's bad news for TRAPPIST-1e. Habitability-wise, back in its own star system, TRAPPIST-1e is the most promising of all its TRAPPIST neighbors. Yeah, it has 6 rocky planetary neighbors. Some of those planets are boiling hot, too hot for any life to exist on them, and some are frozen worlds, but TRAPPIST-1e kinda rocks. It's right in the habitable zone. It's got an atmosphere, land, lakes, and oceans. It even has similar gravity to Earth's. TRAPPIST-1e is no doubt our best candidate for Earth 2.0. Or at least it was before we moved it into Mercury's orbit. Now, any hope we had to make this planet our home away from home would be gone. The cool thing is, in Mercury's orbit, you'd be able to see it from Earth. Yeah, it would be a dot in the sky, but a bigger and brighter dot than Mercury. Even without a telescope, it would appear as a bright star. Another piece of good news is that placing an exoplanet 2.4 times larger than Mercury in that orbit wouldn't cause significant gravitational damage to our solar system. It might nudge Venus slightly, but that would take thousands of years. So yeah, bad news for TRAPPIST-1e, but not so bad for you on Earth. Hey, now that this exoplanet is so close, you could finally land on it. Or really land on whatever was left of this once possibly habitable world. Now, to make things a little fairer for TRAPPIST-1e, we should place it closer to Earth's orbit, like in the asteroid belt. The asteroid belt is this region of space between Mars and Jupiter. It has millions of asteroids in it. But unlike in Star Wars: The Empire Strikes Back, these asteroids aren't closely packed together. The average distance between them is around 1 million kilometers, 600,000 miles. There's plenty of space for TRAPPIST-1e. But the asteroid belt is 2.5 times further from the Sun than Earth is. So in this position, TRAPPIST-1e would only get 16% of the sunlight that we get here on Earth. Once again, bad news for this exoplanet. It would quickly lose all its heat and turn into a frozen wasteland. All of its water would become locked into water ice. At this point, it would no longer be Earth 2.0, it would be a new Mars. If TRAPPIST-1e did have any hint of life, it would be obliterated. Unless that life was beneath the surface and could adapt to this sudden climate change. But here's where things get interesting for our solar system. A planet almost as large as Earth in the asteroid belt would not be good for you. Okay, at first it would be business as usual, but over millions of years, TRAPPIST-1e would yank asteroids out of their orbits. Its gravitational effect would grow, and millions of years later, it would start disturbing the orbits of Mars and Earth. Even worse, it might start affecting Jupiter's orbit. And when that giant of a planet shifts orbit, well, the entire solar system is in danger. Yeah, even a slight shift in Jupiter's orbit would affect all the inner planets. It might even send Mercury crashing into the Sun. But that would take billions of years, so nothing to worry about for now. Okay, clearly TRAPPIST-1e would have no luck in either of these orbits, and placing it too close to Earth would be dangerous for our planet. So let's try moving another exoplanet, Kepler 442b, into one of our spare rooms. Kepler 442b is a heavyweight of rocky planets. It's 1.3 times the size of Earth and packs 2.3 times our planet's mass. It's like Earth on steroids, or as scientists call it, a super Earth. Now, one moment it's orbiting its cool orange dwarf star 1,200 light years away, minding its own business, and the next moment it's teleported to our solar system. But where do we put it? Well, back in its own star system, where Kepler 442b is the one and only rock, it happens to orbit its star's habitable zone. But that star, Kepler 442, is a K-type star, which is cooler and dimmer than our Sun, a G-type star. So 442's habitable zone is way closer. If we replaced our Sun with Kepler 442, that would place Mercury in the habitable zone, and Venus would be just outside of it. But we're not replacing the Sun here. We're just placing Kepler 442b at about 0.5 astronomical units from the Sun. Yeah, a bit closer to Mercury than to Venus. Now, that's no longer within the habitable zone of the Sun, and that means, well, things are about to get hot for Kepler 442b. However, what makes Kepler different from TRAPPIST-1e is that Kepler 442b has stronger gravity, so it would fight for its atmosphere. Yeah, we believe that Kepler 442b is a great candidate for a habitable world. It's bigger than Earth, so it would have a lot more surface to live on. But let's be honest, we're not going to travel 1,200 light years to settle there. And here, so close to the Sun, this planet isn't going to be a tropical destination. It would be hellishly hot. Its oceans would evaporate, but the atmosphere would stick around. And that's a bad thing, because instead of a super Earth, Kepler 442b would become a super Venus. Yeah, all that vapor from evaporating oceans would make its thick atmosphere even thicker. And in the same way that Venus traps its heat on the surface, Kepler 442b would do that too. Except that Kepler 442b is almost 3 times more massive than Venus. Its strong surface gravity would hold on to the thick atmosphere, and after years of intense solar heat, this atmosphere could grow even denser. And if greenhouse gases began to trap more heat, it might end up even worse than Venus. You definitely never want to land there. And eventually, you might not be able to land there, because having a brand new super Earth in the inner solar system, it would shake things up. It would start slowly, and at first, you wouldn't notice anything, but after a few thousand years, Kepler 442b's gravitational presence would push the orbits of Mercury, Venus, Earth, and Mars. After millions of years, Kepler 442b might even toss those planets out of their orbits and make them collide with each other. And as that orbital mashup is unfolding, things would be changing down on Earth too. With an unstable orbit, Earth would have an unstable climate. And if we were on a collision course with Mars or Venus or even Kepler 442b itself, well, that would be the end of our planet. But these events would take at least 1 million years. You wouldn't see any planetary collisions in your lifetime. So let's go bigger and move a planet 5.5 times more massive than Earth. Yeah, Q Ogle 2005 BLG 390LB. This exoplanet is incredibly cold and super far. Yeah, Ogle 2005 BLG 390LB, we'll call it Ogle for short, is 21,526 light years away. Ogle orbits its star at a distance of 2.6 astronomical units. If it were in our solar system, well, it would be sitting in the asteroid belt between Mars and Jupiter. Now, we don't even know what type of star this planet orbits because its star is just too faint and too far away. But it must be some kind of cool star because Ogle is a frozen world. It's colder than anything we have in our solar system. Yeah, Ogle's surface temperature is only 50 degrees Kelvin. That's minus 223 degrees Celsius, or minus 370 degrees Fahrenheit. It's cold. And because we discovered this planet through gravitational microlensing, we don't even know how big the planet is. You see, there's different ways of discovering planets. Telescopes like the Kepler Space Telescope discover planets through the transit method. They look at light blocked by an exoplanet passing in front of its star. Gravitational microlensing is different. It measures the tiny bending and magnification of light from a more distant star. That bending is caused by the gravity of a planet when its host star passes in front of it. So we don't technically see the planet, we just know it's there, gravitationally affecting the light from its star. And that means Ogle could be a super Earth, or it could be a mini Neptune. For the sake of this experiment, let's imagine Ogle as a big, frigid, rocky planet. Now, if we move this planet into our solar system, right in the asteroid belt, it would be a huge change for Ogle. The asteroid belt gets about 16% of the sunlight that Earth does, which is a lot compared to Ogle's original orbit. But it's still not enough, not at first. The surface would remain deeply frozen, but it would warm up to about minus 200 degrees Celsius. But the longer it's in our solar system and the more heat it gets from the sun, Ogle would slowly warm up. Its surface ice would partially sublimate, creating an atmosphere, or adding to its atmosphere if Ogle already has one. Still, it would be too cold for us to land on, so we'd likely just send probes and rovers to explore the surface of this cold planet. Keep in mind that this isn't a small, lightweight planet like TRAPPIST-1e. Ogle is massive, 5.5 times heavier than Earth. It could be extremely dense and have a strong gravitational pull. Within a few million years, it would cause the asteroid belt to fall apart. The asteroids would be ejected of their orbits and flung forward, spiraling toward the sun. And some of those asteroids would take detours near Mars and Earth. Our daily weather forecasts on Earth would be calling for bright sunshine, light solar winds, and a 70% chance of catastrophic asteroid collision. The asteroid belt has millions of asteroids, and at least 1 million of those are a minimum 1 kilometer in diameter. That's 0.6 of a mile. So things would get disastrous fast. Eventually, after tens of hundreds of millions of years, Ogle would destabilize Mars, and once Martian orbit shifted, Earth would be next. So if humanity somehow made it to tens of thousands of millions of years, a giant asteroid might just wipe us out, like the dinosaurs. But things would get much worse, much faster, if we placed an epic super Saturn in an orbit around the sun. This is J1407b, and it's magnificent. It orbits a star 434 light years away from us, and it is truly massive. J1407b is 20 times more massive than Saturn, but its rings are 200 times wider than Saturn's. Yeah, if we placed this alien gas giant in the same orbit as Earth, its rings would reach Mercury. Back in its own star system, this super Saturn orbits 10 to 15 times further from its star than Earth does. So in our solar system, that would place it perfectly between Saturn and Uranus. Now, those giant rings would dominate the sky. They'd reflect so much sunlight that you could see them from Earth. Though in its new orbit between Saturn and Uranus, you'd need a telescope to see them properly. But let's not forget, this planet is massive. It would be tugging at Saturn and Uranus, slowly disrupting their orbits. Over millions of years, this gravitational dance would destabilize moons, shift rings, or even pull Uranus into a more elliptical path. The smaller, icy bodies in the Kuiper Belt would no longer be safe. J1407b's gravitational reach would act like a celestial broom, sweeping entire regions of debris clean or hurling them inward toward you on Earth. Yeah, expect a higher number of asteroid collisions. Now, let's say we wanted to explore this absolutely magnificent giant and its rings with a probe flyby. Well, that could be difficult. Those rings aren't just icy rocks. They're millions of chunks, some as large as mountains, orbiting J1407b at thousands of kilometers per hour. A direct impact would vaporize a spacecraft. Now, J1407b might have hundreds of moons. Some could be larger than Mercury. If they cross into Saturn or Uranus's orbit, they'd crash into those planets. They might even make Saturn and Uranus's own rings bigger and brighter. If J1407b nudged Jupiter even a little bit, the effects could eventually ripple inward toward Earth. Jupiter is the anchor of our planetary orbits. If J1407b disturbed it, it would throw off the entire balance of our inner solar system. Over hundreds of millions of years, those tiny changes would add up. Earth's orbit could wobble. Asteroids would be smashing into us. Mercury might even get flung into the sun. Yeah, it gets chaotic. Imagine a sunset on a planet that orbits a black hole. Or one that stops, reverses, and happens twice in the same day. Or a Martian sunset that turns blue. This is not sci-fi. These are real physics. You see, there are 2 trillion galaxies out there in the universe, and within them, there are billions upon billions, trillions upon trillions of stars. Our Milky Way galaxy alone has at least 100 billion planets. Think about that, 100 billion. Some orbit 2 stars. Some orbit dead neutron stars. Some even orbit black holes. The universe is a strange place, and the view is about to get spectacular. So buckle up. We're traveling from Mercury to the edge of the known universe to witness the most beautiful and deadly alien sunsets you've ever seen. And stick around to see a sunset on a planet orbiting a black hole. In our solar system, Mercury has the weirdest sunsets. The sky here is always pitch black. That's because Mercury doesn't have any atmosphere to scatter sunlight like Earth does. But even though Mercury doesn't have epic twilight, it has something better. Double sunset. Yeah, if you were standing on Mercury, you'd see the sun slow down in the sky and then stop, reverse for a bit, and then fully set over the horizon. That's not a simulation mistake. That's a normal day on this planet. Mercury has a very oval-shaped orbit, and it speeds through it faster than any other planet in the solar system. But when it gets to its closest point to the sun, it speeds up drastically, like a slingshot. On average, Mercury rotates on its axis exactly 3 times for every 2 loops it makes around the sun. But when it's at its closest to the sun for a few days, Mercury is moving around the sun faster than it's spinning on its own axis. And that creates the epic double sunset you can only see once in 176 Earth days. On Venus, you never actually see the sun as a distinct disk in the sky. That's because this hellish planet has an incredibly thick atmosphere, and the atmospheric pressure here is 93 times higher than on Earth. Unlike on Mercury, all you'd see on the surface of Venus is thick, yellow, sulfuric acid clouds. Lots of them. And as the sunset approaches, from the surface of the planet, the sky never turns to starry night. Instead, the yellow glow just deepens into a dark red and then fades into a pitch black night where no stars are visible. But you'd have to wait a long time for this sunset. One day on Venus is 243 Earth days long. That's even longer than a Venusian year, because Venus only takes 225 Earth days to orbit the Sun. But don't mix that up with the solar day on Venus, which is another way of saying a full day-night cycle. That solar day here on Venus lasts 116 Earth days, and the actual sunset isn't a 15-minute spectacle. It lasts for days. Mars has this cold, red desert vibe during the day, but as the sun sets, the sky actually turns blue. Yeah, the reason behind this is that the atmosphere on Mars is very thin, less than 1% of Earth's, and it's filled with teeny tiny dust particles, or iron oxide and magnetite. These particles are microtiny. They're about 30 times smaller than a single strand of your hair. Yeah, if you scale a human hair to the width of a soda can, a particle of Martian dust would then be the size of a single grain of rice. During the day, the iron-rich dust in the Martian thin air scatters sunlight. That's what gives Mars its signature red planet look. But the sunset is where all the physics get flipped. All because of what scientists call me-scattering. Those dust particles are almost as small as the wavelength of blue light, so they don't just absorb blue light, they act like tiny directional mirrors. Instead of bouncing the light everywhere, they scatter the blue light forward. So when the sun is low in the horizon and you're looking right at it, that blue light is beaming directly into your eyes, cutting through the haze. Science. Now, Jupiter is a bit of a bummer because you can't land on its surface. Now, gas giants like Jupiter and Saturn, just the same as the ice giants, Neptune and Uranus, don't have any surface at all. They're just super heavy clouds with cores at their center. So, while you can't see what the sunset looks like from Jupiter's non-existent surface, you can still look at it from Jupiter's cloud tops. From here, the sky would look dark blue, darker than the deepest ocean on Earth. And the sun here is just a tiny, incredibly bright button in the sky, only a fifth of the size we see it from Earth. That's because Jupiter is far. Yeah, it's 5 times farther from the sun than Earth. Okay, Jupiter doesn't have retrograde sunsets or blue sunsets, but it has speed. Yeah, this giant rotates incredibly fast. It makes one full rotation on its axis in just 9 hours and 55 minutes. So, in one Earth day, this giant has the sun setting and rising 2.5 times. What's a half sunset? Anyway, basically it's a sunset on fast forward. Now, while we're hanging around Jupiter, let's take a break from all the planets and look at some of the solar system's largest moons. Io is a volcanic hellscape, the most volcanic moon in the solar system. It spews volcanoes like Earth did in its early days, and it even has an atmosphere. But that atmosphere is super thin and mostly made up of volcanic gases like sulfur dioxide. Because the air is so thin, the sky here is mostly black, even during the day. And sunset here is no regular sunset either. It's a sunset/solar eclipse. Yeah, every 42.5 hours, the sun hides behind Jupiter. And it's not a fast kind of eclipse either. If you were watching sunset on Io, you'd see the sun disappear behind the gas giant for 2 solid hours. And this is Europa. It's quite the opposite from the volcanic world that is Io. This moon is icy. Europa has a very thin oxygen exosphere. It's like an atmosphere, but way too thin. So the sky here is black even during the day. But when the sun finally sets, Europa gets a glow up. Literally, this moon is being constantly bombarded by intense radiation from Jupiter. And all that radiation slams into the ice on the surface and makes the ice molecules release energy as light. So as soon as that tiny sun vanishes below the horizon, the ground beneath your feet would start to shimmer. The landscape would glow with a faint light, like you wouldn't even need a flashlight to see where you're walking. Okay, next up is the solar system's heavyweight champion moon, Ganymede. Yeah, this moon is so huge, it's bigger than Mercury. If it orbited the sun instead of Jupiter, we'd call it a planet. And it's the only moon in the solar system with its own magnetic field. That means a sunset on Ganymede comes with a light show. As twilight hits, you'd see auroras. Yeah, just like Earth's northern lights. Well, almost. The Hubble telescope has detected Ganymede's auroras mainly in ultraviolet, so you wouldn't see them in our simulation. And you wouldn't really see them if you were standing on the surface, unless you used specialized equipment. And finally, Callisto. This rock orbits Jupiter, only much farther away than its other large moons. From here, Jupiter would look about the same as a grapefruit held at arm's length. Now, you'll see the same kind of sunsets as you would on Io, with Jupiter blocking the sky, but Callisto doesn't get an eclipse every day. Yeah, it has a tilted orbit and often misses Jupiter's shadow. You'll have to wait 3 years to see one of these sunset eclipses. Okay, enough with Jupiter. Let's move on to the moons of Saturn. This is Titan, Saturn's largest moon. And it's a special moon. No, it doesn't have volcanoes like Io or glowing ice like Europa. It's got a thick atmosphere, and its atmosphere is even denser than Earth's. But even more than that, Titan is covered with lakes. Only these lakes aren't made of water. These are lakes of liquid methane and ethane. In this thick atmosphere, the sunset would take the landscape from hazy orange to deep brown. And with Saturn so big in the sky, well, what a view! Now, speaking of Saturn, this planet, just like Jupiter, is a gas giant, so no surface to land on. And just like on Jupiter, you'd have to watch the sunset from the cloud tops. But the sunset isn't the main event here. The rings are. During the day, the icy rings reflect sunlight, and as the sun sets, you'd watch the shadow of the planet itself creep across that arch, extinguishing the ring light section by section. It's not just the sun going down, it's the lights going out on the biggest structure in the solar system. Man, I wish Earth had something like that. Okay, past Jupiter and Saturn and all their moons, there's Uranus. This planet is weird. It rolls around the sun on its side, and instead of orbiting it straight like other planets do. Because of this tilt, if you were at the pole of Uranus, you'd have to wait 42 Earth years for the sun to set. It would just spiral around the sky. But when the equinox finally comes and the sun does set, it's beautiful. The atmosphere of Uranus is full of methane, and methane is a gas that absorbs red light. So as the sun dips, the sky doesn't turn orange or pink. It fades from a bright cyan to a deep turquoise color. Makes me feel kind of cold. Next up is Neptune. This is the furthest planet from the sun. I know this because Pluto is not a planet, not officially. Neptune orbits the sun 30 times farther than Earth does, so things here are pretty dim. Out here, the sun is 900 times dimmer than it is on Earth. The sunset on Neptune is a shift from blue to total blackness, so not as spectacular as you might have pictured. Moving on. To Pluto. I know, I said it's not classified as a planet, but it still holds a special place in the solar system, and in my heart, and in the comments section where you're constantly telling me it's still a planet, but it's not. A dwarf planet / X full-on planet, it even has its own moon, Charon. Now, Pluto is even further from the sun than Neptune, so it's even darker here on this rock. If you stood on the surface of Pluto at sunset, you wouldn't see a black sky, you'd see a blue one. A really, really, really dark blue sky. And you could see Charon from here, forever locked in the sky. That's because Pluto and its moon are tidally locked, so here you go, a sunset on Pluto. Now, as sunsets seem to look darker and more boring and more darker and more boring as we get further out in the solar system, well, I think it's time to travel outside our planetary neighborhood. Okay, this is Kepler, but not your favorite 22b. This is Kepler 444c. This one is half the size of Earth. This rocky planet is 119 light years from Earth, where it orbits a dim and small K-type star. But it orbits really close, way closer than even Mercury orbits our sun. So that small K-type star looks massive in the sky. And this rock is Kepler 452b, which scientists often call Earth 2.0, mostly because it orbits a similar sun in its habitable zone. The main difference is that its star is about 1.5 billion years older, so it's 20% brighter than our sun. You see, stars like our sun tend to get brighter when they get older, just before they turn into red giants. So a sunset here would be bright, but very similar to Earth's. And in case you forgot what an Earth sunset looks like, well, here's a beautiful sunset simulation for your reference. Another Earth-like planet is TRAPPIST-1e. Look, it even has auroras and a beautiful atmosphere. But you're not here to watch regular sunsets. You want to see the epic stuff. I get it. And I give you PSR B1257 plus 12c, or simply Poltergeist. It's one of the first planets ever discovered, but it doesn't orbit any kind of star. It orbits a pulsar. This pulsar is called PSR B1257 plus 12, or LIC. It's only about 20 kilometers in diameter. From Poltergeist, it looks tiny. Yeah, that blindingly blue-white point of light? That's the pulsar. Pulsars are extreme. They're neutron stars spinning so fast that they sweep beams of radio waves and other radiation across space like cosmic lighthouses. Some blink just a few times per second, and the fastest pulse hundreds of times per second. It's incredible. This specific pulsar spins 161 times per second, so the sunset here has a bit of a strobe effect. And it goes back and forth like that as the planet turns away from the pulsar and back at it. Things are spinning fast here. Now, this celestial rock doesn't have any nice name. It's called WD1145 plus 017b. Scientists don't bother giving it a more memorable name because it's being vaporized by the white dwarf it orbits. The white dwarf is about the size of Earth, but it's as massive as 60% of our sun. It burns with a hot blue-white light, and with every sunset, it rips the planet or a planetesimal that's left of a planet apart. But this is nothing compared to the scariest of sunsets. The kind of sunset that happens when a planet orbits a black hole. This is an extremely beefy, supermassive black hole, Holmberg 15A star. It's a black hole in the middle of the galaxy Holmberg 15A, which is 750 million light years away. This black hole has a mass of 22 billion suns. Yeah, I'll let that sink in for a second. 22 billion suns. Orbiting something like that would be deadly, but with an unimaginable view. And this is a planet orbiting a black hole in the galaxy IC1101, which also happens to be the largest known galaxy in the universe. This black hole is even more massive than Holmberg 15A star. It has about 40 billion solar masses. And it's way, way farther away, at 1.1 billion light years between this monstrosity and planet Earth. Oh, and this black hole is even more massive. This is Ton 618, and it's got 66 billion solar masses. It's quite a bit farther away at 10.8 billion light years from Earth. Now, scientists think that planets orbiting black holes exist, theoretically, and they could even orbit black holes in stable orbits. But we don't have the technology to observe those kinds of planets just yet. This is What If. And here's what would happen if the sun exploded tomorrow. That star at the center of our solar system, that super hot ball of plasma that gives us heat and energy, and amazing complexions. Well, it's a ticking time bomb. The sun is 4.5 billion years old, but it's only expected to last about another 5 billion years. After that, the sun will expand, becoming a red giant. Then, it will shrink to become a white dwarf, a dying star, cooling for the next several billion years. Of course, we'll all be long gone before any of that happens, but Still, can you imagine what it would be like to watch the sun blow up before your very eyes? With a name like supernova, you'd think that a solar explosion would be the most magnificent fireworks show the world has ever seen. But in reality, you likely wouldn't see anything. The sun is 150 million kilometers away from Earth, and it takes 8 minutes for light from the sun to reach us. And while that may seem super far away, in supernova terms, we don't stand a chance. For Earth to be completely safe from a supernova, we'd need to be at least 50 to 100 light years away. But the good news is that if the sun were to explode tomorrow, the resulting shockwave wouldn't be strong enough to destroy the whole Earth. Only the side facing the sun would boil away instantly. The lucky other half would experience a rise in temperature that would be 15 times hotter than the sun's current surface temperature, and permanent darkness. And without the sun's mass keeping us in orbit, Earth would likely start floating off into space, while its remaining inhabitants desperately struggle to stay alive. There is a chance that our planet could lock into orbit around another star that might provide the same light and heat as our sun, but by the time that happened, we'd all be long gone. If we knew in advance the day that the sun would explode, then we could buy ourselves as many as 1,000 years of time, provided we had the resources to sustain ourselves for that long. And we could. Just a few meters below the ground you walk on, the Earth is maintaining a temperature of about 17 degrees. So if we had enough time to prepare, civilization could continue to live by moving underground into a huge network of fortified bunkers. Within a week after the explosion, the surface temperature on Earth would drop to minus 18 degrees. Within a year, temperatures would plummet to about minus 73 degrees. At this point, the oceans would begin to freeze from the top down. Within 1,000 years, Earth's atmosphere would freeze and collapse, leaving anything left on the surface exposed to cosmic radiation and meteor impacts. Hopefully, by that point, we'd have found ourselves a new home. The good news is that if the sun were to explode, and it will eventually happen, it wouldn't happen overnight. When the sun does die, it will be a long, slow, arduous process taking place over billions of years. The sun will get hotter and brighter, and it will start to expand. During this process, it will lose its outer layers to the cosmos, leading to the creation of other stars and planets, in the same way that the violent burst of the Big Bang created Earth. Who knows? Maybe new life could form. Can you imagine another Earth? A new humanoid species? You could fit over 1 million Earths inside our sun. But you could squeeze over 1 billion suns into the absolutely gigantic star named Betelgeuse. No, not that Betelgeuse. This Betelgeuse is an unstable red supergiant that's rapidly pushing into its final fusion cycles before it detonates into an extremely violent supernova. You really wouldn't want to see this in our neighborhood. If Betelgeuse replaced our sun, it would swallow half of the solar system, and that's before it explodes. Would you survive? Well, it ain't looking so good for you, but let's find out. Scientists aren't really sure exactly how far Betelgeuse is from Earth. We know it's in our Milky Way galaxy, and we estimate it's between 550 to 700 light years away. We also don't know how big and how massive this star really is. That's because this giant is a pulsating mess that's too bright for our telescopes to see more precisely. We know it's between 14 and 20 times more massive than the Sun, and up to 1,000 times larger in diameter. That's over 1 billion kilometers across. What we do know is that it's bright, hot, young, and explosive. As in, it's about to explode. Soon. Sometime in the next 100,000 years. It could happen in 10 years or 10,000. Or tomorrow. It could happen any day. So, what would happen if it explodes? Well, that's one of the most anticipated astronomical events in history. And scientists have been watching closely because lately, Betelgeuse has been acting weird. I mean, Betelgeuse has always been kinda weird. Because it's so close and so huge, it's one of the most studied stars in the sky. And we know it's a highly volatile star. We're talking shock waves and hot spots driven by these massive internal bubbles. Convection cells so big they'd swallow Earth's entire orbit. These convection cells disturb the surface and trigger violent shock waves. All that disturbance creates massive hotspots that make Betelgeuse go darker and brighter, pulsating in cycles that can last years. In 2019, it went through what many astronomers thought was a pre-supernova phase. It was the opening act before the star exploded, an event known as the Great Dimming. Yeah, this massive, super prominent star in our sky just went dark, down to a third of its usual brightness. Scientists eventually figured out that it was because it blew a great chunk of seething plasma into space. That chunk was 400 billion times the mass of the chunks our sun emits. When the dust cooled off, Betelgeuse blocked so much of its own light, we could hardly see the star anymore. That dimming was extraordinarily and highly violent. Kinda like blowing both your pecs off. So, yeah, Betelgeuse is ready to go boom. What will happen when it does? Well, if a star like that exploded in place tomorrow, it would light up our night sky. Even that far away, it would be as bright as a full moon, and it would be visible in full daylight. Betelgeuse is so big and red because it's burned through all of its hydrogen, which means it's burning helium now, and maybe even carbon. And once stars start doing that, well, they also start fusing heavier elements like neon and iron. When Betelgeuse's core is full of iron, nuclear fusion will stop. The core will cool and gravity will overwhelm the star. The core will collapse and the rest of the star will fall inwards towards the imploding core. In a split second, all that star matter will hit the superheated core and bounce off of it as a super violent shockwave. And boom! Supernova. Yeah, when Betelgeuse does go supernova, well, the scale will be so massive that it's almost impossible to imagine. It makes everything on our tiny blue marble feel insignificant. But if there's one thing I've learned from hosting this show, it's that even in a universe of exploding stars, what happens here on Earth matters. And that brings me to a what if that I've been thinking about a lot lately. I'm gonna ask you to do something I wouldn't normally do, and that's sit through this ad. Because even if you don't click on the link, just hearing this message helps. Imagine a world where for every single human being, there are 13 farmed animals. Now, imagine the vast majority of them living in a state of constant systemic suffering on factory farms. To me, that kind of feels like a glitch in our own humanity, because this is not a hypothetical. This is the real world you live in today. I often feel helpless about it. It's like watching a disaster in slow motion. But what if you didn't have to feel helpless? That's why I'm proud to introduce you to the sponsor of today's video, FarmKind. They're trying to help millions and millions of farmed animals who need your help. FarmKind works with experts to recommend 6 top charities working to end factory farming. It's not just another charity, it's more like a real-world what if. Like, what if we could get mother pigs out of crates so they can actually care for their piglets? Or what if we could free millions of chickens from cramped cages? Well, FarmKind works on making those what-ifs real. And they never take a cut of your donation. 100% of what you give goes directly to the organizations helping the animals. If you sign up for just 50 cents a day, that's $15 a month, well, you'll save 350 animals a year from unnecessary suffering. And to really supercharge that impact, well, use my code WHATIF. If you set up a recurring monthly donation, FarmKind will apply a 50% boost to your gift. One-time donations still get a 20% lift, but that monthly commitment is how we truly rewrite the script for these animals. If even a fraction of this community did that, well, we transform the lives of hundreds of thousands of animals. You can find the link in the description just to see how much your donation can do to help. It's never been so easy to change lives. And while we have the power to save lives here on Earth, there isn't much you can do when massive stars go supernova. For Betelgeuse, well, that would be the end of its days. But it's a good thing. Because when massive stars like Betelgeuse end their life cycles in a violent cosmic explosion, they scatter elements like carbon and iron in the nearby space. All those elements that are crucial to life. Without the death of stars like this, well, life wouldn't exist. You and I and our iron-based blood wouldn't be around. Okay, if Betelgeuse went supernova exactly where it is now, it would release so much energy that you'd see it with the naked eye. But what would that kind of energy do to Earth? Well, the good news is 600 light years, give or take, is still way too far to deal with any kind of damage to our planet. By the time the gamma rays and X-rays from the explosion reached Earth, they'd spread out way too much. Yeah, they wouldn't be powerful enough to breach our magnetic field or damage the ozone layer. Plus, it would take a long time for any gas and matter from the dying Betelgeuse to reach our solar system. I mean, it could take millions of years. No, to see some real supernova danger, we'd need to move this enormous dying star a little closer to home, like 160 light years from us. Yeah, this is exactly how close a star needs to go supernova to shake things up down here on Earth. If Betelgeuse was sitting 160 light years away from us, it would be far bigger and brighter in the sky. And it's already famously bright, one of the 10 brightest stars in the sky. You've already seen it, even if you didn't realize it. It's this bright star anchoring Orion's shoulder. What's so cool about Betelgeuse? Astronomers have been watching it for so long that we have first-hand observations from ancient Greek astronomers. And, surprise, Betelgeuse used to be a different color. Which means that even in our brief civilized time on this planet, humans have watched it go from a pale yellow to the reddish color we see today. Now, what would happen if that star went full thermonuclear blast at 160 light years away? Well, it would be bright. Like, brilliant. Lighting up the night bright. The explosion would shower Earth in X-rays and poke holes in the ozone layer. And yeah, you really need Earth to have its ozone layer. Because it's like a premium planetary sunblock. Except instead of a greasy lotion, It's a thin layer of gas high in the sky, keeping you from being literally cooked. This gassy layer acts as a giant shield that absorbs the sun's harshest UV radiation before it can hit the ground. Without it, you'd get brutal sunburns in minutes of being out in the open. And with enough of this radiation, your DNA would get all wrecked. Now, Betelgeuse going supernova 160 light years away from Earth, it wouldn't shred the ozone layer to pieces, but it would cause extra mutations to plants and animals. Extra skin cancer, extra northern lights and southern lights. Well, auroras everywhere. But it wouldn't wipe humanity out. Actually, this kind of explosion likely did happen in the last 10 million years, and Earth is still here today. Now, if we move Betelgeuse even closer, well, that's a different story. If we moved Betelgeuse 50 light years from Earth and it went supernova, well, its explosion would be deadly, like mass extinction event deadly. And to give you a sense of how dangerous this supernova is, this explosion would take place nearly 500 trillion kilometers away, and still it would destroy our entire ozone layer. Suddenly, you'd have zero protection against the sun's UV rays. And maybe you're thinking, no big deal, just put on some more sunblock. The problem is, you can't put sunscreen on phytoplankton and reefs. The sun's radiation would decimate them, and that's dangerous because the reefs and the plankton are the foundation of Earth's food chains. Those food chains would collapse, and die-outs would ripple upwards from single-celled organisms to apex predators. That's mass extinction. Earth would be showered with gamma rays and radiation, and our atmosphere would be swamped with smog like nitrous oxide. It would be bad news for our climate. And you wouldn't last very long in these harsh conditions. Hopefully, though, you'd get a glance of the supernova exploding so close to Earth just before our planet burns up. Because if we moved Betelgeuse to the center of our solar system, you wouldn't have time to witness a supernova. You'd die long before Betelgeuse explodes. Alright, if we replaced our sun with Betelgeuse, well, that would be a dramatic killer event. Betelgeuse is not just a star, it's a monster. Remember, you can fit 1.2 billion suns inside of it. So, if you were standing there on Earth, looking up at the sky when this happened, what would you see? Well, not much. There wouldn't be a sky. Earth wouldn't orbit Betelgeuse, it would be inside it. Yeah, our entire planet would be engulfed in a stellar inferno. Because that's how enormous Betelgeuse is. For a fraction of a second, you'd see the brightest reddish-orange flash you've ever seen, and then you'd be incinerated. Yeah, you and the rest of the creatures on planet Earth would be reduced to ashes, air-fried, barbecued. You know, actually, despite its size, Betelgeuse is actually pretty cool for a star. Its surface is only about 3,200 degrees Celsius. That's 5,800 degrees Fahrenheit. The sun's surface is a lot hotter at 5,500 degrees Celsius. But still, that's more than enough to cremate every living thing on Earth in real short order. In other words, you'd be dead. So, you wouldn't have to wait around for Betelgeuse to go supernova. Like I said, Betelgeuse is gigantic. It's so big, it's got a diameter between 640 to 1,000 times our sun. Now, scientists measure the distance between the Sun and Earth in astronomical units. Specifically, that distance is exactly 1 astronomical unit. Betelgeuse would stretch 3.6 to 4.6 astronomical units in all directions. Yeah, it wouldn't just swallow Earth. Mercury and Venus would be gone too, as they're even closer to the Sun than Earth is. Even Mars would be inside this violent supergiant. If Betelgeuse replaced the Sun, there wouldn't be 8 planets in our solar system. There would be only 4. Maybe even 3, because Jupiter would now be dangerously close to this supergiant. If you really wanted to avoid being toasted, you'd have to be out by Saturn. At this point, you might as well just move to Pluto. Now, Jupiter would be in a pickle. Being the closest planet orbiting Betelgeuse, it would turn into a hot Jupiter, which is actually a thing. Hot Jupiters are a class of some of the first exoplanets we ever found. They are superheated gas giants in tight, low orbits around their star, with temperatures ranging in the thousands of degrees. Most hot Jupiters orbit much smaller stars with orbital periods of 12 days. But Jupiter would go around Betelgeuse in 12 years. It's likely that Betelgeuse would cook Jupiter along with the inner solar system's planets. All that hydrogen and helium that Jupiter's made of is perfect fuel for Betelgeuse. And Jupiter's icy moons would just melt. If there was any life hiding in the oceans of Jupiter's moons, well, those Jovians wouldn't be so jovial. Yeah, okay, that is a nasty space dad joke. In any case, though, Jupiter would get hot, if it survived at all. But here's the thing, you somehow predicted this violent solar system change and moved out to one of Saturn's moons, like Titan. Well, from here, the sky would be a deep blood red orange color. Much of the ice in Saturn's rings would melt and vaporize, blasted into space by Betelgeuse's stellar wind. Titan's atmosphere would puff up from the heat. It would stop raining methane and it would just start raining. Scientists have actually studied this idea to explore what would happen in 5 billion years when the Sun expands into a red giant. Though they didn't factor in a supergiant, so they'd have to adjust their math. They also didn't factor in this. Yeah, Betelgeuse comes with a little surprise. A second star in orbit around Betelgeuse. Scientists just discovered that the red supergiant is actually in a relationship. That is, it has a companion star. It's a unique binary star system. And scientists didn't notice this companion until recently, because Betelgeuse is so big and bright. This young, new blue-white star is similar in size to our Sun, and about 1.5 times the mass of our Sun. Compared to Betelgeuse, though, it's a tiny dot. It's also orbiting Betelgeuse at a distance of about 4 astronomical units. That means if we teleported Betelgeuse and its companion to our solar system, we'd have this new, smaller star in the range of Saturn's orbit. Yeah, Saturn could be on a collision path to real trouble from Betelgeuse's companion star, the ominously named star Beetle Buddy. Beetle Buddy? Beetle Buddy? Yeah. Well, that's the boatiest McBoatfaceest name for a star I've ever heard. And nicely done, Jared. Okay, it sounds like Jared Goldberg and his colleagues who discovered this companion star formally named it Alpha Ori B. I still prefer Beetle Buddy. In any case, it's goodbye Saturn, and probably goodbye Beetle Buddy. Well, we hardly knew you. Yeah, scientists figure that Beetle Buddy's going to be pulled into Betelgeuse within 10,000 years anyway, so if we replace the Sun with Betelgeuse, Well, either Beetle Buddy would get consumed by the red supergiant, gut shot by Saturn, or blown to pieces in a supernova. Okay, after Betelgeuse and Beetle Buddy swallow the inner planets and blast Saturn and Jupiter to cosmic dust, what would be left of the solar system? Well, you've still got Neptune and Uranus, and Betelgeuse, like any star, would create a new habitable zone around itself. Because Betelgeuse is about 100,000 times more luminous than the Sun and up to 1,000 times its diameter, the new habitable zone would be pushed way out to about 316 astronomical units. That's 10 times further out than Neptune, way out past the Kuiper Belt. All those icy objects floating in the dark corners of the solar system, like Triton and Pluto, would suddenly get a lot of heat from the new Sun. Even further out, trans-Neptunian objects like the potential dwarf planet Sedna or even the mysterious planet X would be the best places for life to survive. Well, small chance of that, but still. Even with this new habitable zone, there wouldn't be enough time for life to emerge on any of the planets beyond the Kuiper Belt, because Betelgeuse is about to blow. Remember the supernova? Yeah, it's happening. If Betelgeuse went supernova from the center of our solar system, it would release a blast of energy bigger than our Sun will ever produce over its entire 10 billion year lifetime. Imagine every ray of sunshine that will ever hit Earth compressed into a burst lasting just a few seconds. Well, that's Betelgeuse going supernova. By then, though, Earth would be long gone, and the remaining planets would be obliterated. You can kiss Uranus goodbye. Hey, I mean, we haven't had a good Uranus joke in 2026 yet. And that's the only one we're doing, I swear. I mean, probably not. But whatever, it's right there. Yeah, anyhow, as the explosion cleared, the solar system, would be gone, replaced by a massive glowing nebula. This explosion would forge an expanse filled with heavy elements like gold and platinum, seeding the galaxy with the raw materials for new stars and planets, and even life to take our place eventually. So that's what would happen if we swapped our Sun with Betelgeuse. And I can gladly say that it's not happening anytime soon. Actually, never. The Sun stays in its place, and Betelgeuse will inevitably explode about 600 light years away from us. But it does make me think about dropping other objects into our solar system. Like, what if a black hole or a neutron star replaced our Sun? Well, that's a story for another What If. If our Sun suddenly turned into a magnetar, we'd all be cooked, and pretty quickly. Magnetars pack about 1.5 times the mass of our Sun into an incredibly small space. They're tiny and super dense remnants of ancient stars that have gone supernova, and they have an unimaginably powerful magnetic field. Yeah, this little star would kill everything on Earth, including you. In this video, we'll show you how life would change or end if we replaced our star with some of the most extreme objects in the universe. Some of these, surprisingly, could be better for us than the Sun. But before we get into it, We want to hear what object you would want to replace the sun with. Why not tell us your pick in the comments below? Okay, now let's test them all out, starting with a red giant.
Oh my god! Oh dear! Are you filming? Yes, I'm filming!
The bad news is that the sun really will swell up into this kind of red and hot exploding star. And